Hello, Algebra 2. Today we're going to be taking a look at section 6.2, which will be a continuation of our conversation on the inverse trig functions, where in this section we'll be taking a look at the inverse secant, cosecant, and cotangent functions. But before we do that, I want to look at a couple of warm-up problems that will cover some of the main concepts that we learned about in the last section. So this will be your chance to kind of see what you know, what you don't know, and it'll give you a better idea of how well you understand your inverse trig functions. So I want you to take a couple minutes to work this out, pause the video, and as usual, press play when you're ready. So the way I'm going to work out this problem is by working inside out. And by that, I mean I'm going to first evaluate sine of 7 pi over 4. Now, if you don't remember what sine of 7 pi over 4 is, you can always draw your angle 7 pi over 4 in standard position. This would be an angle that lies in quadrant 4. In particular, I care about the reference angle, which in this case is just pi over 4. And so because my angle is in quadrant 4, I know that sine takes on negative values there. If you remember, you can use the ASTC, right? All students take calculus, where I know cosine is a trig function that's positive there, which means that both sine and tangent are negative. And so because I know sine of 7 pi over 4 is a negative number, I'm going to put a negative here. And then from there, I can find sine of the reference angle. Sine of pi over 4 is just root 2 over 2. And so from here, going back to the original problem, I can rewrite the question as inverse sine of negative root 2 over 2. Now, if you remember our discussion in the last lesson, I know that the inverse sine of this number is an angle. There's a couple of things I know about this angle, theta. I know that sine of theta is equal to negative root 2 over 2. And I know that theta lies in the interval between negative pi over 2 and pi over 2. And then from here, I know that my angle is going to be in quadrant 4, because sine takes on negative values there. In this case, because the reference angle for theta is pi over 4, I know that my final angle will actually just be negative pi over 4. So one thing to watch out for is the reason why I like to work inside out is because I tend to make less mistakes that way. What I'm worried is if you see a problem like number 1, you might think that the inverse sine and the sine just cancel each other out, and then you're left with 7 pi over 4. But that would be incorrect because of the fact that 7 pi over 4 does not lie in this interval. And so this would be incorrect, right? So by working inside out, you just have a greater chance of minimizing those kind of mistakes. So looking at number 2, I'm going to do the same thing. I'm going to work inside out. I'm going to first find tangent of 2 pi over 3. Tangent of 2 pi over 3, which is equal to negative square root of 3. And so I know that I can rewrite this as the inverse tan of negative square root of 3. And once again, I know that this is equal to some angle theta, where tangent of theta is equal to negative square root of 3. And I also know that theta has to lie in this interval here between negative pi over 2 and pi over 2. If you compare this interval with that for sine inverse, they're very similar, except for inverse sine, the endpoints are included. For inverse tangent, the endpoints are not included. So from here, you need to figure out tangent of what angle gives me negative root 3. If you remember your unit circle, you should end up with negative pi thirds. And then lastly, for number 3, same deal, work inside out. I'm going to first find sine of 7 pi over 6. If you don't remember how to find sine of 7 pi over 6, you can again always draw your angle in standard position. Here my angle is in quadrant 3. In particular, I want to look at the reference angle right here. My reference angle is just pi over 6. So what that tells me is that if I want to find sine of 7 pi over 6, I first note that my value is going to be negative because sine is negative in quadrant 3. And then ultimately, I just have to find sine of the reference angle. If you remember, sine of pi over 6 is just 1/2. So rewriting this, I can write this as cosine inverse of negative 1/2. And again, just like we did before, I know this is equal to some angle theta. And the question is, what is theta? I know that cosine of theta is negative 1/2. And I know that theta lies in the interval between 0 and pi. So hopefully you have these angles memorized or you can figure them out on your own. But I know that my angle is going to be in quadrant 2. And I know that my reference angle is going to be pi over 3, which means that my angle has to be 2 pi thirds. And so one thing I want you to note is the fact that with all three of these problems, right, the inverse trig function was on the outside. And so we worked inside out, and in the end, your final answer was some angle. Now, looking at these next type of problems here, they're a little bit different because if you notice now, the inverse trig function is on the inside. So what we're going to do, though, is the same thing we did before. We're going to work inside out. So I'm going to first look at cosine inverse of 1 over 5. Now, the thing is, I don't know what the inverse cosine of 1/5 is, right? It's not an angle on the unit circle. But what I do know is that this is an angle nonetheless. So I'm going to call cosine inverse of 1/5 theta. And so let me just rewrite that here. And so what this tells me then is that cosine of theta is 1 over 5. And I know that theta lies between 0 and pi. And so from there, I want to figure out what quadrant theta lies in. And so because cosine of theta is positive, and I know I'm between 0 and pi, I know that my angle has to be in quadrant 1. Because cosine is positive there. Let me call this theta. I want to draw a right triangle. And from there, I want to label my sides of this right triangle. Now, if you remember SOHCAHTOA, cosine would be adjacent over hypotenuse. So I can call the adjacent 1, I can call the hypotenuse 5, and then using Pythagorean theorem, right, a squared plus b squared equals c squared, and solving for the third side, you should get square root of 24, which if you simplify this, you'll get 2 rad 6. Now going back to the original problem, I'm really just trying to find sine of theta. And then from there, I want to first figure out is my answer going to be positive or negative. Now because my angle theta is in quadrant 1, I know sine is positive there. So I'm expecting a positive answer. And then I can use the fact that sine is opposite of hypotenuse. The opposite is 2 rad 6, and the hypotenuse is 5. And this would be my final answer. So make note of how this problem was different than the ones we did before. I didn't know what the inverse cosine of 1 over 5 was, but I knew it was some sort of angle. And so based on that, I was able to draw a picture, right? And then label the sides appropriately using your trig definitions. And then from there, just answer the question. So let's look at another example here together. Just like we did before, note that the inverse sign is on the inside. I'm going to work inside out. So once again, this is just some angle theta. I know that sine inverse of negative 3/4 is equal to some angle theta. And there's a couple things I know about theta. I know that sine of theta is negative 3 over 4. And I know that theta has to lie in the interval between negative pi over 2 and pi over 2. So what that tells me then is that theta must lie in quadrant 4. Quadrant 4 is where sine takes on negative values. You can always use all students take calculus. So once again, I'm going to draw my right triangle. Let me call this theta. Now from there, I know that sine is opposite over hypotenuse. So I'm going to label the opposite side 3 and the hypotenuse 4. And then from there, you'll use the Pythagorean theorem to find the third side, which you should get to be square root of 7. Now from there, I'm going to rewrite this as tangent of theta. Now the first thing I'm going to do is figure out whether my answer should be positive or negative. Now because my angle is in quadrant 4, using all students take calculus, I know cosine is the only trig function that's positive among sine, cosine, and tangent. So that means that tangent needs to be negative there. I'm going to put a minus sign. And then from there, I know that tangent is opposite of adjacent, right? That's the TOA in SOHCAHTOA. The opposite is 3, and the adjacent is square root of 7. From here, you do want to rationalize. Multiply the top and bottom by square root of 7. And if you carefully simplify this, you should end up with negative 3 rad 7 over 7. So hopefully you're getting the hang of how to do these kind of problems, right? Again, make note of the fact that the inverse function is on the inside. It's an angle we don't know. So we'll just call it theta and go from there. So at this point, I want you to try number 3 on your own. As usual, pause the video, and when you're ready, press play. So for number 3 here, just like we did before, I'm going to work inside out. I'm going to call this here theta. And so a couple things I know about theta is that tangent of theta is negative 2/3. And I know that theta needs to lie in this interval here. What this tells me then is that I must be in quadrant 4 because tangent takes on negative values there. So just like before, I want to draw a triangle in quadrant 4. Here's theta. And I know that tangent is opposite over adjacent. So I'm going to label the opposite side 2 and the adjacent side 3. Using Pythagorean theorem, I'll get the hypotenuse to be square root of 13. Now from there, I'm going to rewrite this problem as secant of theta, which I'm going to rewrite this further as 1 over cosine of theta, because I just like working with cosine better. Now, the first thing I'm going to do is figure out, is my answer going to be positive or negative? Now, because I'm in quadrant 4, I know cosine is positive there, so my answer is going to be positive. And then from there, I can find cosine of theta by taking adjacent over hypotenuse. That will give me 3 over square root of 13. And if I simplify this, I'll get square root of 13 over 3. So make sure you note the difference between what we've been doing now and the previous problems. Understand that the inverse trig functions are in the inside, and these are angles that are not the unit circle. And so because of that, we don't know what theta is for any of these problems, but we can always draw a picture that represents theta, and we can go from there. So make sure you review all this content before you move on to the next lesson.